Welcome to the walkthrough for Part A of Assignment 2, which focuses on the Java Executor Service Framework and ultimately on various other types of synchronizers than we covered in Assignment 1. The objective of Part A of this assignment is to learn how to use the Java Executor Service Framework. Videos describing the Java Executor Service appear on my YouTube playlists. I recommend you watch these videos to ensure you understand the Java Executor Service. Naturally, we'll also be covering these topics in class as well. In this part of the assignment, you use an instance of the Java Executor Service class that's created as a fixed-size pool of threads to enhance the multi-threaded implementation of the Palantiri Simulator app from Assignment 1A. Assignment 2A focuses on creating a pool of threads that allow beings to gaze concurrently into a fixed number of Palantiri. By now, you should understand what Palantiri are. The Palantiri Simulator app is packaged as a project in Android Studio version 3.3. This app is written both in Kotlin and Java and demonstrates many Android capabilities. For the purpose of Assignment 2A, however, you only need to be aware of the following three directories. First, the Simulator Manager's Beings Executor Service directory, which contains the skeletons you need to fill in, as we'll discuss further below. There's also the App Service Test directory, which contains a set of JUnit tests that exercise many Palantiri Simulator features and can be used to help you test the functionality that you implement for the assignment. Finally, there's App Service Android Test, which is an Android Studio instrumentation test that stresses your application automatically. To compile this code, you'll need to use the provided Android Studio project. As always, you can run this project by clicking the green Run App button in the Android Studio Interactive Development Environment, which should automatically prompt you to select an Android emulator to run, assuming you have one created, of course. The application's minimum API is 24, so you'll need to select an emulator that uses API greater than or equal to 24. If you've not already created one, you can create it by clicking on the AVD Manager button in the Android Studio IDE. You'll need to modify several files containing the Java skeleton code and completing the to-do you fill in here task to provide a working solution. Make sure you don't change the overall structure of the skeleton. Just fill in the to-do tasks. Also, make sure you leave the to-do comments so I know where to look for your changes. In particular, you'll need to finish implementing the following to-do tasks for this assignment in the Executor Service folder. The Executor Service Manager.java file contains a number of to-do tasks that you'll need to complete to fill in various methods that implement a being manager via a fixed-size thread pool using the Java Executor Service. You'll also need to make some changes to the being callable.java file, completing several methods in this class. In addition, you'll need to complete the to-do comments in the assignment.java file, which will set the S-types field to either graduate or undergraduate, depending on which version of the assignment that you'll be implementing. In addition, you'll need to integrate your solution for the spinlock hashmap folder from Assignment 1B into the latest, greatest spinlock hashmap skeleton and use it as the implementation of the Palantiri Manager for Assignment 2A. In the forthcoming Assignment 2B, you'll revise the Palantiri Manager solution to use different types of Java synchronizers. Your app will be considered correct if it passes all the unit instrumentation tests and all the beings successfully complete all their n iterations. A correct simulation should restrict the number of gazing beings to the number of Palantiri that were selected when you run the program. In other words, if there are 4 Palantiri in the simulation, then only 4 beings should ever be gazing on the screen at any given time. While the simulation is running, the app view will display visual feedback to show Palantiri and being states, as well as the progress of their gazing iterations. If your assignment implementation is correct and doesn't throw any exceptions, the app title bar's labels will appear green when the simulation completes. However, if the implementation throws an exception or isn't implemented correctly when the simulation completes, the red title bar labels will be displayed when the program is finished. Graduate students, or students who are taking this course for graduate credit, must perform the following additional tasks. They'll need to enhance the Executor Service Manager.java file to use Java 8 streams and associated features, such as method references or lambda expressions. Undergraduates are welcome to implement these methods and features, but are not required to. The source code for this assignment is available from my GitHub account. In particular, if you click here, it'll take you to the assignment location, which, as usual, you should clone and pull into your repository. Since you've already set up your GitLab account, you should be able to pull the skeleton code in your repository. Read through the skeleton carefully, read through the spec carefully, and complete the to-do markers. The additional work required by graduate students is clearly marked by the to-do comments. This assignment is designed to deepen your knowledge of writing concurrent Java programs using a thread pool, which complements the core Java multi-threading mechanisms we covered in Assignment 1A. So far, you're not required to program any Android-specific concurrency or communication frameworks, which we'll cover in upcoming assignments. Now that we've walked through the specification of the assignment, let's take a look at the skeleton code, starting with the Executor service folder. As you can see, there's a class here called being callable, which extends being and implements callable with an instantiation of the type of the callable being a being callable. That's kind of a curious recursive implementation. As you can see here, some of the methods are provided for you. You'll have to implement the being callable method. As you can see, you need to simply replace the to-do, implement the to-do by replacing null with the appropriate return value. That's pretty straightforward. And then here's the acquire Palantir and gaze method. You can essentially cut and paste this from your previous implementation because it's essentially the same thing. Let's go take a look at a more interesting class. This is the Executor Service Manager class. And this is essentially a being manager implementation that uses the Java Executor service, which will create a pool of Java threads in order to run the being simulations. This is a being manager instantiated with a being callable. We just looked at that. You'll have to go ahead and make a list of futures to being callables that are going to be running concurrently in the Executor Services thread pool. You'll have to make an instance of the Executor service, which will contain the fixed pool of threads. There's a default constructor. You can ignore that. You have to fill in a couple of getter methods. These are used by the unit tests, so you have to fill them in. And basically, you can use these below. Instead of accessing those fields directly, you can access them by calling the getter method. So one, of course, will return the future list. One will return the executor. Down here is the being callable new being method that returns a being callable. It's a factory method, so you can fill in the code, replacing null with the appropriate implementation. Run simulation requires you to call a couple of methods that are explained here. These methods are then implemented down below. One method is called begin being thread pool. And what this will do is create an executor service instance that will create a fixed sized pool of threads, where there'll be one thread for each being. So that gives you a hint as to how big it needs to be. You'll then call the get beings factory method to iterate through the being callables, submit each of these being callables to the executor service instance, and then take the future that comes back to the list of being callable futures and add it there. The grad students have to do the same semantics, but they have to do it using a Java 8 stream. Undergrads are welcome to use the stream, but it's not required. The other method that needs to be implemented is called await completion of futures. And this will essentially spawn a thread that will wait for all the futures to complete. And inside that thread, there'll be a for each loop that will be used to wait for all the futures to complete. And if things work well, then you should tell the controller log to indicate that things worked. If an exception is thrown, then you have to catch the exception and tell the controller log which exception was caught. The grad students need to use a Java 8 stream instead of a for each loop. Once again, undergrads are welcome to use it, but they don't have to. Here's the shutdown now method. This method will essentially go in and cancel all the outstanding being callables via their futures, and then shut the executor down now. And then finally, it goes ahead and logs things to the controller logger. You can see here that controller.log is the method that you should be calling up in await completion of futures in order to indicate what has happened. So those are the main methods you have to implement. Then, of course, the other thing you'll need to do is you'll need to come over here into the spinlock hash map folder, and you'll have to cut and paste your implementation from before
for the various methods that are required to make the spin lock hash map manager and a spin lock or a reentrant spin lock. Most of this code is very similar to before. The only things that are really different is that there are a couple of new methods, a couple of new getter methods, get spin lock and get available Palantiri, and you'll need to implement these to return the appropriate field that's defined up here. And this is again used by the unit tests. So that just helps to consolidate things, put them in one place, give them a clear, identifiable name. So that's basically what you have to implement as far as the code goes. Not really a very hard assignment, but it'll teach you how to use the various pieces necessary in order to be able to make thread pools. And then in assignment 2B, we'll come along and we'll replace the spin lock hash map manager with a more interesting implementation that uses reentrant locks as well as some other mechanisms in order to be able to coordinate access to implement a so-called simple semaphore. But that will come in assignment 2B.
I'll now show you how to run the JUnit tests. It's very important to run these tests while you're doing your assignment and certainly before you do your initial submission. And naturally, by the time you do your final submission, you need to make sure that all these tests work. If you go over to the edu.vandy.simulator folder and you go ahead and right-click on it and click on Run Tests in Simulator, it should go ahead and essentially compile the project if you haven't already compiled it. As you can see down at the bottom, it's executing the tasks to go ahead and build everything. And once those are built, it will then go ahead and begin to run. Okay, so you can see that it's beginning to run. There's quite a number of different tests that are in here. If you take a close look, you can see that some of these tests are rerunning the reentrant spin lock tests from assignment 1B. Those are left over from before. Naturally, all those should continue to work with the new assignment. There's also some assignment 2A tests. We have tests that are running the Executor Service Manager. We have tests that are running the 1B spin lock hash map manager tests, and so on and so forth. You can see we're running the spin lock tests. It's also running the assignment 2A being callable tests. And if all goes well, which it should, if you've got a correct implementation, then all of the tests you see here should be green. If for some reason something goes wrong, you'll end up with oranges or reds, in which case you'll also get some indication on the right-hand panel over here what has gone wrong. So make sure that you run the tests, take a careful look at the output, and if for any reason whatsoever you don't know what the results mean or they don't work in the way you expect, please come to office hours and ask questions. So the last thing I'm going to show you in this walkthrough is how to go ahead and run the instrumentation tests that stress your implementation. So if you go over here and find the EDU Vandy app Android tests and right-click on that and click Run, it'll prompt you to either set up or choose an Android emulator. I'm going to pick the one that I already have running here. Let's go down here. As you can see, that's going to go ahead and load in the app. Starts running the tests. If you take a look over here, you'll see that we have 10 beings and 6 Palantiri. Each of the beings is doing 10 iterations. This test program is exercising a variety of different features, such as the ability to do runtime configuration changes. You can also see it's keeping track of how many iterations it's performed. It's keeping track of how long it took to run. Everything worked properly, so as a result, the results are green. It goes ahead and runs this a couple of different times to really put the test to the paces. You can see here it's turned the speed up quite a bit, so it's going super duper fast. You probably wouldn't normally run it this fast if you're trying to just watch the output, but this is trying to do kind of a stress test. As you can see, when you're all done, we get a message saying that everything passed, and that's a good sign because that means that our program is working properly. Hopefully your program will also work properly as well, and hopefully this video will help you have a better idea of what the specification is, what you have to implement for the skeletons, how to run the unit tests, and how to run the instrumentation tests.